In this video, you will learn to find the x and y intercepts, foci, and length of the major axis of an ellipse, as well as how to determine an equation of an ellipse. So the first question is, what is an ellipse? Well, it's basically like an oval, all right? But our definition would be the set of all points, P, in the plane such that the sum of the distances from P to two fixed points called foci is a given constant. Now this is kind of wordy, so you might be struggling to understand what this would look like. But for example, okay, we said it's going to be kind of like an oval, so something that looks like this right here. And we have for every ellipse what we call the focus, or foci is plural. All right, so we have two foci here in the ellipse. And any point that we take on the ellipse, let's say we take this point right here, point P, the distance from focus 1 to point P plus focus 2 to point P, if you add those together, you'll always get the same number. You can pick any point. If you pick a point over here, okay, the distance from that to F1 plus the distance from there to F2, you add those together and you get the same number back out. So that is what we mean by an ellipse, and that's what our definition means. Now, where do you see an ellipse in everyday life? Well, there's different places you might see this, but one of the most common or most familiar places would be with the orbit of planets. So planets orbit the sun in an ellipse, where one of the focus, or one of the foci, is going to be the sun, and the other focus is just a random point out in space. All right, so that is one major application of ellipses. Now with an ellipse, we have a equation that we can use, and right here, an equation like this, where you have x squared over a number plus y squared over a number equaling 1, this would give you an ellipse if you were to graph. Now we're not going to go through the process of plugging in numbers to prove this to be true. You can do that on your own time. But what you have is going to be a graph that looks like this, where the center is going to be at 0, 0. And then we also have x and y intercepts. All right, so we see it here in the graph very clearly, but if you were to try to find this on your own, what you do to find the x-intercepts is we plug a 0 in for y and then solve for x. All right, so that's going to give you your x-intercepts. If you plug a 0 in for y, we have x squared over 25 plus 0 squared over 16 equals 1. So this would just cancel out. You're left with x squared over 25 equals 1. Then multiply both sides by 25 to get x squared equals 25. And then you take the square root of both sides of that equation to get x equals a plus or minus 5. So with that being said, we have our x-intercepts, and we see that here at negative 5, 0, and 5, 0 here and there. We can also go through the same process to find our y-intercepts. Where does it cross the y-axis? Well, to find this, you could plug a 0 in for x. So you have 0 squared over 25 plus y squared over 16 equals 1. So we can then solve this for y. So this first term would cancel out, so we have 0 over 25. And then here we have y squared over 16 equals 1. You could then multiply both sides by 16 to get y squared equals 16. And then take the square root of both sides to solve for y. So y would equal a positive or negative square root of 16, which would be 4. And that's what we see right here and right here. So those 2 points are at 4 and negative 4. So this is very helpful for us because we can find those 4 points, and then if we were to graph that equation on our own, you can just connect with a curve, and you have your graph very quickly. All right, so kind of a shortcut way, instead of going through all of this process to find the x and y intercepts, notice for the x-intercepts, if you simply take the number underneath the x term and take the square root of that, that gives you your x-intercepts. And then for the y-intercepts, you take the 16, which is under the y term, and take the square root of that to get your y-intercepts of 4 and -4. So you could go through all this process of solving like we did here, but you could just realize you take the square roots of the terms, the numbers under the x and then under the y terms. And then we have what's called the foci, which is plural for the word focus. So we have one focus and another focus. So plural, we have foci, F-O-C-I. And those we see here at -4, 0 and 4, 0. And in a moment, we're going to walk you through how to find that just based off the equation. But it's not maybe very intuitive to find just by looking at it. All right, and then we have what's called the major axis, which is going to be a segment connecting the -5 and +5. So if you make a segment from here all the way across to here, that's going to be your major axis. And it's going to be the longer length, all right? So it's longer than what's called the minor axis. The minor axis goes the shorter distance. In this case, it's across from 4 down to -4. And that would be your minor axis. So it makes a difference, which way it's being rotated. So like here is longer, like from left to right, but it could be up and down like this. Okay, if it's up and down like this, your major axis would be this vertical line from here to here, and the minor axis would be across left to right like this. So it just depends on which segment is longer. That's the major axis, the longer one, and the minor axis is the shorter one. All right, so we've kind of seen the relationship between those intercepts and the graph. We want to go a little more in detail to be able to figure out different foci as well, to figure out how to find those. All right, so with an equation of an ellipse, all right, we have two different ways we can have this. So we have x squared over a squared plus y squared over b squared equals 1. Or the b squared could be under the x term, and the a squared goes under the y term. So what's the difference and similarities between these two equations? Well, for both of these, a squared is always larger than b squared. And that's the difference between these two equations. So for the first one, the larger number is below the x term, whereas for the second equation, the larger number is under the y term. So with both of these equations, the center is going to be at 0, 0. For the first one, the major axis is going to be horizontal. And we know that because the larger number is under the x term, so x is left to right. So from left to right, it's going to be larger than from up and down. So it's going to look something like this. All right, so across is longer because the number with the x term is longer. And then for the other one, the a squared is with the y term. So with that being said, the major axis in this case will be vertical. It's going to be like this, where it's going to be up and down. So the major axis is longer in the vertical direction. All right, now for both of these, the length of the major axis is found by doing 2 times a. All right, so whatever a is, it'd be like the distance from the center to a point, you double that to get all the way across. So a is like from the center to a point, either to the right or the left. So put it together to get the length of the major axis, which gives you 2a. Same thing for over here. So again, the center is right here at 0, 0, and then up to the vertex, or one of these points, one of the intercepts, is going to be a, and then down to the bottom is also a. So together, a plus a gives you 2a for the length of that major axis. Now the other thing we mentioned is the foci of both of these ellipses. So the foci would be 2 points like here and here, or here and here on the ellipse. Now to find that, okay, we realize that the center is here at 0, 0. So from 0, 0, we need to go to the right and to the left to find the foci. So you're adding some number, we'll call that c, to the right, and then we have to subtract c to get to the left. So c is going to be the distance from the center to a focus. All right, so the x value is changing, so it's going to be negative c and positive c. The y value is staying the same. It's not going up or down at all. Same concept over here with this ellipses. With this ellipse over here, we have our major axis being vertical, and our foci are going to be found by adding and subtracting some number. So that number is, again, c, and then we have to subtract c to get down. And here is going to be the y number, the y value of the ordered pair that's changing. So for this focus, we have to do negative c and positive c for the y value. The x value stays the same, and it's going to be 0. All right, so that's the relationship. And right here we see this equation we put in. So this equation is kind of like the Pythagorean theorem, but it's got a minus instead of a plus sign. And what this does is it relates for us the c and the a and the b values. All right, so if needed, we can find the foci by plugging in these two numbers, a squared and b squared. So if that was like 4 and 16, for example, we would just plug in 4. I guess a is always bigger, right? So it'd be, I guess, 16 and 4, 16 minus 4. So you just plug those numbers 16 and 4 in, and we solve for c. So c would be the square root of 12, plus or minus. We can use that to find the foci. All right, and we'll do that here in a moment. So now that we know the relationship between the equation and all these different components of the ellipse, we can now use this information to find the equation. So if you're given pieces of information, we can work backwards and try to derive an equation from that. So the first example here we have is given the intercepts. Okay, how can we find the equation given the intercepts? So we have two examples. First one, we have the x-intercepts as being a plus and minus square root of 3, and the y-intercepts are a plus and a minus 2. Now to do this, all right, realize our equation is going to be x squared over something, and then plus y squared over something equaling 1. Now remember we said that we can just look here at these numbers underneath to find the x and the y-intercepts, right? So it's kind of like that, but working backwards. So basically what we do is if we square each of these, so like square the square root of 3, that gives you just a regular 3, right? That's going to be the number under here with the x term. All right, because remember we said that the shortcut was to find the intercepts. We take the square root of that to find the intercepts. All right, so it's working backwards. Same thing down here. We took this term and we took the square root to find our answer. So to go backwards, we want to square both sides. So we square the 2 and negative 2. They both would give you a positive 4 back out. So our number underneath would be 4, because if we took the square root of 4, that would give you a plus or minus 2, which we see right here. So basically just square the square root of 3, and we square the 2 to get our numbers 3 and 4 underneath of the x and the y term. So for example 2, why don't you try this one on your own, see if you can come up with the equation for this one. So as you're working through, it's going to be x squared over something plus y squared over something equals 1. So to find those numbers underneath, we take the intercepts. So if we square the 7, that gives you 49. That goes under here with the x squared term. And then if we square 4 times square root of 2, we square that. We have to square the 4, and we have to square the square root of 2. That gives you 16, and this would give you 2. So that gives you 32 right there. So the number underneath would be a 32. And that would be your answer. It would be x squared over 49 plus y squared over 32 equals 1. Now what if you're given other pieces of information instead? So for example, let's say we were given the foci to be negative 4, 0, and 4, 0, and the major axis length was 18. So what we want to do in this example is we're going to want to, I guess maybe set up our equation. So it's going to look something like this: x squared over something plus y squared over something equals 1. All right, so first off, we know this is going to be a squared and b squared in one of these two places. And the foci, remember we mentioned the foci gives us the c value. C is the distance from the focus to the center. So we see the distance from the focus to the center would be 4. Right, the center is at 0, 0 for these equations. Right, that's right in the center of negative 4, 0 and 4, 0. So our c value is 4. And then our a value we can find, because remember we said a is the distance from the center to a point on the major axis. So if the length of the major axis is 18, so like here the length is 18, then halfway is going to be 9. All right, so this is going to be 9, this is going to be 9, so a is going to be 9. All right, so a is 9, c is 4. We can use that to find b, because remember we said the relationship between a and c is c squared equals a squared minus b squared. So you can plug in the 4 and the 9 for c and for a. We got 16, so 4 squared, and then 81 for 9 squared, and then solve for b. So we can subtract 81 from both sides. That would give you a negative b squared equals, that would be a negative 65. So positive b squared would be positive 65, and then b would be the square root of 65, which we actually really don't need. We just want the b squared number. So we see that typed up down here. And now the foci, we said, are at negative 4, 0 and 4, 0. Be here and over here. So because we know that information, we know that the major axis is going to be horizontal like this. So what that means is that the x squared term is going to have the larger number. All right, so that's going to be the a, goes there. So a, we said it was 9. So this was going to be a squared, and this would be b squared. So your equation is going to be x squared over a squared is 81, plus, and then y squared over the b squared, which was 65. And that's equal to 1. So your equation is going to look like this. Let's try one more example, and this is similar to the last one. But here we have the foci are at 0, negative 6, and 0, 6, and the length of the major axis is 24. All right, so when you're doing this, it may be helpful to draw a picture at some point. So your center is going to be at 0, 0. Your foci, 0, negative 6, that's going to be down. X is 0, y is negative 6, 2, 3, 4, 5, 6 right here. And then up 6 for the other one. So it's going to look like that. And the length of the major axis is going to be 24. All right, so we can use this information to kind of get an idea of our picture and what's happening. So c is the distance from your center to a focus. That's going to be c. So c would be 6. That's the distance from the center up to the focus. Now the length of the major axis is 24. All right, so we know that the major axis is going to be the entire length all the way across, and a is going to be halfway across. So if you were to kind of sketch a picture over here, if this is going to be your peak, the highest point, and this is your center at 0, 0. Okay, if the length of the major axis from top to bottom is 24, this is a, it's going to be half of that, which is 12. All right, so a is half that, which is 12. So we have a and c, and we can use this to find our b value as well, which we'll need for the equation. Now the relationship is that c squared equals a squared minus b squared. So if you plug a 6 and a 12 in for c and a, we would have 6 squared or 36, and then a squared would be 12 squared or 144, and then solve this for b. All right, so we can subtract 144 from both sides. That gives you negative b squared equals, and that'd be a negative 108. So positive b squared would be a positive 108, and then the square root of that, if you want it, the square root would be the square root of 108. So we see that all typed up right here. And from this point, we can start putting together our equation. So because the foci are on the y-axis, so because it looks like this here, it's going to be a vertical ellipse. So the major axis is going to be vertical. All right. So with that being said, when you do your equation of x squared over b over something plus y squared over something equaling 1, we know that because it's up and down, it's vertical, the larger number, the a squared, must go with the y term. All right, so that we know it's going to be this equation right here. So a squared would be 144, and then b squared would be 108. So your final answer would be x squared over 108 plus y squared over 144 equals 1. So this is our equation of the ellipse. So in this lesson, we learned about ellipses and how to graph. We learned how to find the intercepts, the foci, the length of the major axis. We also learned how to come up with an equation based off any of that information. And that concludes our lesson for today. We will see you next time.